I'm here to talk about a model. It's a story that starts in Germany 90 years ago with a struggling PhD student called Ernst Ising. He was talking to his supervisor who said, "Ising, do you ever wonder, when a lake freezes over, how can trillions of randomly oriented water molecules just align so that, yes, it becomes ice? Or when iron becomes a magnet, how can so many atoms align so that a compass always points north? Have you ever wondered?" And Ising said, "No." So they set on a journey. Ising then used one of the most powerful tools in science. He made a model. And by that, I mean that he didn't care about the nitty-gritty details of water chemistry or magnets. No, he just took the details, the key features, and made a much simpler version of things that align. He made arrows. Arrows that could be aligned. Maybe not be aligned, but they would rather be aligned with their neighbors. And that's all. It turns out that's actually enough to explain how fish swim in shoals or how birds fly in flocks. They're just trying to stay aligned with their neighbors. And in fact, it doesn't even have to be physical alignment. For example, if I give you three topics for you, three concepts for you to say how much you care about them, things like democracy, freedom, safety, and I tell you to point. If you only care about the first concept, point in the x-axis. Or if you only care about the second one, point in the y direction. If you only care about the third one, point in the z direction. If you care about all of them, point somewhere in the middle. Maybe closer to the one you like the most. And this will give each one of you a direction. Each person will have an arrow. And yes, if you have your arrow in isolation, that's cool. But once you see your neighbor's arrows, you might feel like tweaking it to bits to align with them, and actually they'll do the same. And what's the big picture? What will I see from here? I'll see the formation of small groups that sort of agree. People over here will think one way, people over there think another way, people over here think this way. And actually, that's just what you see if you look close to a magnet. Yes, a compass does point north on average, but if you zoom in with the right kind of microscope, you will see part of it that points north, parts of it that point this way, parts of it that point other ways. And physicists call these ferromagnetic domains. And this is amazing. How a simple idea about arrows moving can talk about fish or birds, magnets, and even opinions. So yeah, she doesn't like Gucci or Versace, but I tell you, at the age of 90, the Ising model is as beautiful as ever. Thank you.